Alright, this is going to be a video for section 8.1, form G, and I'm going to do problems 13, 14, 15, 26, 28, 29, and 33. Okay, and if I am running out of time, I'll have to chop this up. I'm going to try and do it all in one video, but I might have to break it up depending on the size and the duration it takes me to answer these questions. So let's get started. The first one we're obviously going to do is number 13. It says a square has a side length of 10 yards. What is the length of the diagonal of the square in simplest radical form? Okay, well, a square, again, as I said, if you watch the 8.1 form K video, has every side length is the same. And it has 4 right angles. So I'm only going to use one. I'm just going to work this triangle right here. This is the diagonal. So if I kind of ignore, if I ignore the half of that square that I don't need, I'm only going to focus, obviously, on the triangle. And I just got to find that diagonal. So that's pretty straightforward, just Pythagorean theorem. 10 squared plus 10 squared, and this is obviously my hypotenuse because it is opposite the right angle, is equal to x squared. When I solve this, I get 100 plus 100 equals x squared, and that gives me 200 equals x squared. If I go to square root this, 200 is not a perfect square. The biggest perfect square that divides into 200 is 100, and its partner will be 2. That's your perfect. It is 10. 2 is not perfect, so 10 radical 2 yards is your answer there for number 13. Okay? Now, for number 14, the next one. Similar premise. This one's different. It says a square has it. Now I'm giving you the opposite information. A square has a diagonal length of 9 meters. What is the side length of the square to the nearest centimeter? Okay, so out of all the new stuff, you got to pay attention to your units. We'll kind of worry about that last. We'll make sure we get the Pythagorean theorem part down perfect. There's a question similar to this on 8.1 form K that I've already posted. But I'll do this one too. So again, in a square, all the side lengths are the same. So you can call it whatever letter you want to call it, but all 4 sides are the same length. And again, you have 4 right angles. I'm only going to draw one, and I'm going to again work on this triangle down here on the bottom left. Okay, so I don't need this information. I'm just going to focus here. Okay. So to set this up, again, 9 is the hypotenuse because it is across or opposite of that right angle. X squared plus x squared is equal to 9 squared. I add these together to get 2x squared is equal to 81. Okay. Now, in order for me to do this, they don't want it in simplest radical form, which is good news for us. I can divide both sides by 2, and that gives me x squared is equal to 40 and a half. So now in your calculator, square root both sides. When you take the square root of 40 and a half, you get 6.36 and change numbers after 6.36. So that is your answer in meters. Okay? The question is asking for it in centimeters. Now, I don't want to spend a lot of time on this, and I would if we were obviously, in a traditional classroom setting, but I think you learn this in physical science or chemistry or at some point. King Hector died by drinking chocolate milk. If you're ever concerned on how to convert the metric units, really, really easy. Base would be where your meters are. This C is centi. Okay, so I need to move, I'm going to go from meters to centimeters. So I'm going to move the decimal place 2 places to the right. So 1, 2 would give me 636. Or if you just know to multiply 6.36 times 100, you would get the same answer. I'm not too worried about you converting meters. I want you to know how to use the Pythagorean theorem. If that doesn't make any sense to you, if we get back to school here in May, I'd be happy to spend more time on that with you. Okay? But if you can at least use the Pythagorean theorem and solve, if you can only get to 6.36 as your answer, then that's totally fine with me, given the circumstances. All right, number 15. This is just like I think number 14 on 8.1 form K. Again, you get to see my wonderful artistic ability here. A repairman leans on the top of an 8-foot ladder against the top of a stone wall. The base of the ladder is 5.5 feet from the wall. About how tall is the wall? Round to the nearest tenth of a foot. Well, again, as I said in the other video, we always assume the wall or a tree or whatever to make a right angle to the ground. Okay? And the ladder here is said to be, what, 8 feet? So 8 feet. The base of the ladder is 5 feet from the wall, which would be here. Again, this is obviously not drawn to scale. They're asking for the height of the wall. So again, once the picture's there for you, I think most of you guys are probably going to turn the video off because you know what to do at this point. But real quick, 8 feet is obviously my hypotenuse. So x squared plus 5.5 squared is equal to 8 squared. That would be your setup. When you do this, you get x squared plus 30.25 is equal to 64. Okay, I'm running out of room here. Minus your 30.25 from both sides, you get x squared is equal to 33.75 square root, and x is, after you do all of your rounding, 5.8 feet. I hope you guys can read that. I know it's kind of shoved in there, but yeah, I mean, once you see the picture and the setup for the Pythagorean theorem, I think you guys are strong enough algebraically to go ahead and solve all of that. All right, so that is all for that page. I'm going to keep going here, and we're going to move on down to the back page here. I'm going to question number 26 now, and I totally understand why this question was sent to me by multiple students. You have no problem setting this up. I know that for a fact. Okay, as long as you can identify that this is your hypotenuse. If you're unsure of that, you could just type this expression in your calculator and get these to both be decimals, and you would see this is the biggest decimal. Okay, or I know the picture kind of saves you a little bit because I think you'd all know this would probably be your right angle, or probably is your biggest angle between the two other angles in the triangle. But nevertheless, we need to figure out if it is a right triangle or not. So we would take leg squared plus leg squared, so radical 207 squared plus 15 squared has to equal 12 radical 3 squared. Now notice the way I wrote it, I put this and this in parentheses. If you want to use your calculator, and I have students when we're brick and mortar, when we're face-to-face in the classroom, kids screw this up all the time because they type it in their calculator, but they don't put these parentheses around it, and they say the calculator gave them the wrong answer. Well, no, you typed in, the calculator gave you exactly what you typed in. If you square something that is square rooted, okay, all that's going to happen is the square root and the squared are going to be undone, and you just get 207. Oops, not equals. Plus 15 squared is 225. Now, this, again, if you just type this in your calculator exactly as I have it written, you'll be okay. Or, because you all taken Algebra 1 last year, you know that the exponent applies to everything inside of the parentheses. Well, there's an exponent on the 12 of 1, and radical 3, like we just said, a radical 3 squared is undone. So this actually will just become 3. 12 now squared is 144 times 3, which is 432. Okay? So again, if you're confused on that or need to see more, email me, and I'll give a bigger spiel on that. But if you type it in exactly in your calculator as I have it, you have parenthesis 12 multiplication button, radical 3. Make sure your cursor comes outside of being under the radical. Okay, close the parentheses, and then hit squared. Your calculator will give you exactly the 432 that you need if you type it in exactly like I told you. Now, when I add 207 and 225, I do get 432. So I got a true statement. Therefore, that triangle is a right triangle. Okay? Moving on to number 28. And again, we're back to these circles and stuff inside of a square inside of a circle. So I'm going to draw the picture. It tells me that a square is inside of a circle such that all the vertices of the square are on the circle. And then it says the radius is 15 feet, centimeters, just kidding, it's 15 centimeters. They're asking for the, I should probably read the whole question, what is the perimeter of the square? Okay, well, all radii of the same circle are the same value. So if from here over is 15, that means from here over is also 15. So if I were to redraw my triangle, the whole hypotenuse is 30. And now this is just like what we had before. We don't know the lengths of a square, but we know that they're all the same value. So whatever letter you want to use to call it, they're all x. That's what I'm going to use. So now when I go to solve my formula here, x squared plus x squared has to equal 30 squared. Well, I get 2x squared is equal to 900, because 30 squared is 900. Divide both sides by 2. X squared is equal to 450. And at this point, on a test or quiz, I don't think I'm going to make you do something this big, but you need to find the biggest perfect square that divides into 450. That answer is 225, and its partner is 2. 225 is a perfect square. Its square root is 15, radical 2. But again, that's not the answer. That's just the length of one of these sides. Okay, so let me actually just go ahead and clean this up here. So we just found out that every single one of these lengths is 15 radical 2. Because we found one side length of a square, that means all the side lengths of a square. Well, they're asking for the perimeter. Well, the perimeter is very, very easy. All you do when all of these have the same radical after them, they all have radical 2, you just take 15 plus 15 plus 15 plus 15, which is 60. The radical 2 doesn't change. Centimeters. Okay? I know that's a lot. You're adding radicals, which again is all stuff you learn in Algebra 1. But the Pythagorean theorem thing is something I want you to make sure you guys are good at, because this is the second question now I've answered where you have to come up with an equation. I didn't mean to just erase that. Where you have to come up with an equation that looks like this and be able to solve it. So if you can at least get to here, well, really, truthfully, you should be able to solve the whole thing, because we've spent a lot of time on this. Okay, but you'll be in good shape. Don't worry about if you're not sure on finding the perimeter and everything. I'm not worried about that at this point. So that was 28. I think I got to do 29. So 29, again, you're going to need a picture. You're talking about a football field is 300 feet long and 160 feet wide. And they're saying if a person ran from diagonal from one corner to the other, how far would they run? Well, let me try and at least redraw this a little bit more closer to scale here. Okay, so this would be your 160. That would be your 300. If you go from corner to corner, how far are you traveling? Well, all football fields are right angles. So it's just a straight Pythagorean theorem here. 300 squared plus 160 squared is equal to x squared. Okay, in your calculator, when you do all of that math, you will get 90,000 plus 25,600 is equal to x squared. When you add these values up, you should get 115,600 is equal to x squared. Square root both sides. The square root of 1,115 and 600 is actually perfect. It's 340 is the length of a diagonal, not 360, 340 from corner to corner. It's goal line to goal line for those of you that are big football gurus. All right. Lastly, now this question looks absolutely terrible. The numbers get big, which can make it problematic, but once you actually see it, it's super, super easy. It's just big numbers. So they're trying to figure out this length, okay? And they're talking about, I'm not going to read the whole thing. It's some space theory, I don't know. But the bottom line is they're looking for this length right here. And so you obviously got to use Pythagorean theorem. You're given a right triangle, but the problem is you don't have this value right here. Well, think about what I said earlier about radius of the same circle are all congruent. Well, this length is a radius of a circle. It's 6,370 kilometers long. Well, that means that this piece is also 6,370 kilometers. So for me to find the whole hypotenuse of this value, I just simply need to add 350 to that 6,370 to get the length of the entire hypotenuse. Okay, so the whole hypotenuse's length comes out to be 6,720, and that'll obviously be squared. And then I have my x squared plus my 6,370 squared. Now these numbers get very, very big. Just obviously use your calculator and hopefully everything works out nicely for you. X squared is equal to, when you square 6,370, you get 40,576,900. Should be a plus sign. So x squared plus 40,576,900 is equal to 45,158,400. Okay? Now you want to minus, if I don't run out of room here, you want to minus your 40 mil from both sides. When you do that, you get x squared is equal to 4,581,500. And then when you square root both of those, they asked you to round, not to find the simplest radical form. You just got to round that. So just type that into your calculator, and it should spit out something close to 2,140.4 kilometers. Okay? All right. If there's anything on here that you emailed me asking for and I did not do, please email me, and I will be more than happy to get that video up as soon as possible. Again, if you have any other questions, email me, snydere@nhsd.net. Hope you guys are staying safe and enjoying the nice weather today, and I will talk to you soon. So long.